Okay, welcome to the channel. Today we are going to discuss some basic concepts of chemistry. Today we are going to do some question practice. So here, when you open the video, pause it for some time and observe the question and then play. Now first question. Choose the correct statement about 1 and 2 and 3. 1 and 2 have definite value but 3 does not have this property. 1 and 2 and 3 are interconvertible by changing the condition of temperature and pressure. In the particle of 1, freedom of movement is learned, both A and B. So here, as you can see by this question, here option D. Now second question. Few quantities with their units are listed below. Mark the units which are not correct matched. So we have to observe these options and find out the wrong ones. So as you can see here, Planck constant is not right because Planck constant is Kelvin joules into second, and also force is equal to F is equal to ma, mass into acceleration. So m1 l1 t minus 2. So these both are wrong. So option C. Now question number 3, matchings. So we have to match this. Here as you can observe, pico for 10 power minus 12, femto for 10 power minus 15, milli for 10 power minus 3, and giga for 10 power 9. So here option D would be right. So answer will be 3, 4, 2, 1. The question number 4. Mark the conversion factor which is not correct. So we have to find out the wrong one here. So here as you can see 1 inch is not equal to 3.3 because 1 inch equals to 2.5 centimeters. So here option D would be wrong. Now question number 40, question number 5. So we have to find out the relationship between Fahrenheit and Celsius scale. So option C here because Fahrenheit degrees which is equal to the 9 by 5 of degrees Celsius plus 32. So option C. Now question number 6. Few figures are expressed in scientific notation. Mark the incorrect one. So we have to find out the incorrect one here. So here option B would be wrong because 8.0018 into 10 power 3 would be right answer for option B. Now question number 7. Mark the rule which is not correctly stated about the determination of significant figures. Zeros presenting two first non-zero digits are not significant. Zeros between two non-zero digits are not significant. Zeros at the end or right of the number are significant if they are on the right side of the decimal point. All non-zero digits are significant. Yes. So here option B would be wrong because zeros between non-zero digits are not significant, but practically they are significant. As you can see 101. Here significant figures are 3. So option B would be right. Here as you can see 102. Here the significant figures are 3. Now question number 8. Which of the following rules regarding the significant figures and calculation involving them is not correct? The result of an addition or subtraction is reported to the same number of decimal places as present in number with the least decimal places. Result of multiplication or division should have same number of significant figures as present in most precise figure. The result of multiplication or division should be rounded off to same number of significant figures as present in least precise figure. The non-significant figures in the measurements are rounded off. So here option B, the significant figures are rounded off to the least decimal place. So option B would be right, not most precise figure. Now question number 9. The result of operation of 2.5 into 1.25 should be the which of the following on the basis of significant figures. So here, as you can see, 2.5 into 1.25. As you can multiply this one, the answer will be like, if any multiplication is wrong, please mention in comment. So here the rounding of the numbers would be to the least precise figure. So here 2.5, just like that. Here the answer would be like 3.1. So here the answer would be 3.125. For most precise figure, we take the least significant figures. So here rounding off would be like 3.1. As you can see, we take this, and here the answer is 3.1. So option C right. Now question number 10. How many significant figures are present in 0.01010 into 10 power 3? Here as you can see, these are taken into consideration. So significant figures are 5. So option B. Now question number 11. What will the answer in appropriate significant figures as a result of addition of 3.0223 and 5.041? So we have to add these numbers and we have to round off them. After addition, as you can see, 8.063. So here 4 significant figures are taken into consideration because 5.041 here 4 significant figures. So option B would be right. Now question number 12. Which of the following is the most accurate? Here as you can see, I misplaced the wrong question. So which of set of figures will be obtained after rounding up the following up to 3 significant figures? So here the 3 options. This question is for question number 13. So I forgot to mention and skip the question, unfortunately. So please stay attentive here. So when we round off question number 13 to 3 significant figures, here as you can see, option B would be right. Now question number 12. Which of the following is the most accurate measurement? As you can see, 9 meter, 9.0 meter, 9.00 meter. So here 9.00 meter is accurate, most accurate. So option D would be right. Now question number 14. Sorry, 14. Which of the following options is not correct? So we have to find out the wrong option here. So check the options here. So here option D would be wrong. 0.0048 into. So here 48 into 10 power minus 4 would be written. So as you can see 4. 4.8 into 10 power minus 3 or 48 into 10 power minus 4 is written. It should be written there. Now question number 15. What should be the volume of milk which measures 5 liter? So 5 liter converted into meter cube times. So 5 into 10 power minus 3 into meter cube is written. So option A here right. Now question number 16. How many seconds are there in 3 days? For 3 days it is 3 into 24 hours into for 1 hour it is 60 minutes. For 60 minutes it is 60 seconds. So when we multiply these all numbers, so the answer will be 259,200 seconds. So option A would be right. Now question number 17. 18.72 grams of substance X occupies 1.81 centimeter cube. What will be its density measured in correct significant figures? So we want here density. For density, mass by volume. So here mass 8.72 grams and volume 8.1 centimeter cube. 1.81 centimeter cube. So as you can see, so we have to round up the least precise significant figures. So least precise would be 3. 3 significant figures. Answer would be right. So as you can see here, 3 significant figures are least. So the answer would be 10.3. So option A right. Now question number 18. 4.88 grams of potassium chloride trioxide when heated produces 1.92 grams of oxygen and 2.96 grams of potassium chloride. Which of the following statements regarding the experiment is correct? The result illustrates law of conservation. The result illustrates the law of multiple proportions. The result illustrates the law of constant proportion. None of the above as followed. So here, when we add the reactants and the products, so products are which is equal to the reactants. So masses are equal in reactant sides and product side. As you can see, when we add products, the answer would be same. So here, law of conservation is followed. Option A is right. Question number 19. How much mass of silver nitrate will react with 5.85 grams of sodium chloride to produce 14.35 grams of silver chloride and 8.5 grams of sodium nitrate if law of conservation of mass is followed? So here, as you can see, reactants are 5.85 plus X, which produce 45.35 grams of silver chloride plus 8.5 grams of sodium nitrate. Now X is equal to, this will goes that way, and when we add the both, and minus of 5.85. So the answer will come out as 17 grams. So option C right here. Now question number 20. What mass of hydrochloric acid is needed to decompose 50 grams of limestone? So first here we have to write the equation calcium carbonate plus HCl. Now here calcium carbonate atomic molecular weight is 100 and for HCl it is 71. 100 grams of calcium carbonate require 71 grams of HCl. For 1 gram of calcium carbonate requires 71, 73 by 100 for 50 grams into 50. So this is 36.5 grams of HCl is needed. So as for options, option A. Now question number 21. Which of the following statements best explains the law of conservation of mass? 100 grams of water is heated to give steam. A sample of N2 gas is heated at constant pressure without any change in mass. 36 grams of carbon combines with 32 grams of oxygen to give 68 grams of CO2. Here law of conservation is followed. 10 grams of carbon is heated in vacuum without any change in mass. So option C here. Now question number 22. What mass of sodium chloride would be decomposed by 9.8 grams of sulfuric acid if 12 grams of sodium bisulfate and 2.75 grams of hydrogen chlorides were produced in a reaction? So we have to write first the equation. NaCl plus H2SO4 gives NaCa sodium bisulfate plus hydrochloric acid. As you can see here, sodium chloride is unknown, remaining are known, given in question. Now X is equal to 12 plus 2.75 into minus 9.8. So it follows law of conjugation. So we just simply do a minus, just subtraction. The answer will come out. So 4.95. So option C would be right. This is the answer. Now question number 23. Sorry, here this question is for question number 24. I wrongly skipped 23 question, but I will cover it in next time. So as you can see, 24th question. The following data are obtained when dinitrogen and dioxygen react together to form different compounds. So here masses of dinitrogen and oxygen are given. We have to find out which laws it obeys. As you can observe, here masses are given like this. So here when you observe, these are in a ratio of 1:2:1 and 3. So here law of multiple proportion is applied. So option C would be right. Now question number So this is a dubbing. That's why I'm telling in now question number 23. Sorry for the inconvenience. In an experiment, 2.4 grams of iron oxide on reduction with hydrogen gave 1.68 grams of iron. In another experiment, 2.7 grams of iron oxide gave 1.89 grams of iron on reduction, which lie is illustrated from the above data. Here, iron oxide and iron data is given. As you can see, when you subtract the iron oxide mass with the iron, you will get to the oxide mass. So as you can see, 2.440 minus 6.8, you get oxide amount as 27, okay, 0.72. And as you can see, another data in that particular question in another experiment, the iron and oxide for first experiment, the iron and oxide ratio are 2:1. Now we are going to the second experiment. Here iron oxide is 2.7 grams and the iron is 1.89 grams. By this way, when we subtract, we get oxygen mass as 0.81. Now the ratio of iron and oxide in that compounds 1.89 by 0.84. So here also same ratio 2 by 1. So here option law of constant proportions is valid. Here the ratio is constant. Now question number 24. Sorry, 25. Question number 25. Which of the following statements illustrate the law of multiple proportions? An element forms two oxide XO and XO2 containing 50% and 60% of oxygen respectively. The ratio of masses of oxygen which combines with 1 gram of element is 2:3. Hydrogen sulfide contains 5.89% of hydrogen and water contains 11.1% of hydrogen and sulfur dioxide contains 50% of oxygen. 3.47 grams of barium chloride reacts with 2.36 grams of sodium sodium sulfate to give 3.88 grams of barium sulfate and 1.95 grams of sodium chloride. So here law of conservation is valid. 20 ml of ammonia gives you 10 volumes of N2 and 30 volumes of H2 at constant temperature pressure. Here Avogadro's law is present. So here option A would be right because it follows law of multiple proportions, as you can see XO and XO2. Now question number 26. Here which of the following pairs will illustrate the law of multiple proportion? So as you can see option B is applied for that. Now question number 27. The statements for law of chemicals combinations are given below. Mark the option which is not correctly matched. Matter can neither be created nor destroyed. Law of conservation of mass. Okay, a compound always contains exactly the same proportion of elements by weight. Law of definite proportions. Okay, when gases combines, they do so in a simple ratio by weight. Gay classic law. Wrong. Option C here, equal volumes, that was Avogadro's law, which is right. Now question number 28. Given below are physics statements. Mark the statement which is not correct. Atoms are neither created nor destroyed in a chemical reaction. Law of definite proportion states that a given compound always contains exactly the same proportion of elements by weight. K-Lussig's law, chemical combination is valid for all substances. No, not valid for all substances. A pure compound has always a fixed proportion of masses of its constituent. Okay, Gay-Lussac's law valid for only gaseous substances only. So option C would be wrong. Now question number 29. A balanced equation for combustion of methane is given below. CH4 plus 2O2 gives CO2 2O2. Which law of the following state is not correct on the basis of chemical equation? 1 mole of CH4 reacts with 2 moles of oxygen to give 1 mole of CO2 and 2 moles of water. 1 molecule of CH4 reacts with 2 molecules of oxygen to give 1 molecule of CO2 and 2 molecules of water. 22.4 liter of methane reacts with 44.8 liter of oxygen to give 44.8 liter of CO2 and 22.4 liter of water. 16 grams of methane reacts with 64 grams of oxygen to give 44 grams of CO2 and 36 grams of water. Here option C would be wrong because for 20.4 liter of methane reacts with 44.8 liter of oxygen gives 22.4 liter of CO2 and 44.8 liter of water. So now question number 30. Option C is right, wrong for question number 29. So 30, question number 30. Which of the following law of chemical combination is satisfied by the figure? Law of multiple proposition, Dalton's law, Avogadro's law, law of conservation. Here Avogadro's law is valid. As you can observe by the diagrams, here constant value, Avogadro's law valid here. Now question number 31. Which of the following statements about Avogadro's hypothesis is correct? Under similar conditions of temperature and pressure, gases react with each other in simple ratio. Under similar conditions of temperature and pressure, equal volumes of all gases contains same number of molecules. Would be right. At NTP, all gases contains same number of molecules. No, gases always react with the gases only. No, temperature and pressure. Now question number 32. The reference standard used for defining atomic mass is option B. Now question number 33. Atomic masses of elements are usually fractional because, as you can see, they exist as a mixture of isotopes of different masses. They contain impurities of other atoms. They are mixtures of isomers. They cannot be weighed accurately. Option A. They exist as a mixture of isotopes of different masses. Now question number 34. Oxygen in nature as a mixture of isotopes. As you can see, these isotopes having the masses of 15.99. These atomic masses are given. Relative abundance are given like this. Respectively, what is the average atomic mass of oxygen? So here we have to find out the average atomic masses. So we need a percentage of abundance into that atomic mass by total of percentage of abundance. So here I'll take round figure values. So as you can see, I'll take a round figure those values. Please mention in your mind like this. Okay, please note this. Now 16 into 100, 17 into 0.37. So I'll write as a 0.04 now by 100. As you can see, the value will come out as, when you add and subtract by 100, 16 into 10 power 2, by 100. We cancel like this. So answer will be 16. Round figure value. I have taken the round figure value. Approximate. So option may able to be right. Please check the answer. Okay. If anything wrong, please mention. Question number 35. For every one C37 isotope, there are three Cl35 isotopes in a simple chlorine. What will be the average atomic mass of chlorine? So we want average atomic mass. One into 37 plus 35 into 3, because for one chlorine 37 isotopes there is a compound where one of them is Cl37 and other is 3 Cl35s. So as you can see, 1 into 37 plus 35 into 3 by 1 plus 3. So here 140 by 4, 142 by 4. Here average atomic mass is 35.5. So option C right. Now question number 36. Carbon occurs in nature as a mixture of C12 and C13. The average atomic mass of carbon is 12.0011. What is the abundance of C12 in nature? Here average atomic mass is given. So here C12 is X. We have to assume it as X. Now C13 is 100 minus X. By this 12 into X into 100 minus X into 13 by 100, which is equal to the average atomic mass of 12.11. So here as you can see, when we solve this question, now this one goes that way and it will become like this. The answer will be 98.9%. So C12 is most abundant. No, option B is right. Now question number 37. Packing of Na plus and Cl minus in a sodium chloride is depicted by the given figure. Choose the correct option regarding the formula of mass of sodium chloride. In the solid state, sodium chloride does not exist as a single entity. Formula of mass of sodium chloride is 68.0 micro. Formula mass of sodium chloride is the sum of atomic masses of sodium chloride, both A and C. See, here sodium 23 and Cl for 35.5. Here the atomic weight is 58.5. So option D would be right for both A and C, because B is wrong, right? Now question number 30. Which of the formula is not correctly depicted? So you have to find out the wrong 1 in the options. As you can check the options. Here wrong one is option D. Now question number 39. What is the mass of carbon dioxide which contains the same number of molecules as are contained in 40 grams of oxygen? So when we check this question carefully, mass of carbon dioxide which contains the same number of molecules as are contained in 40 grams of oxygen. Molar mass of oxygen is 32 grams, which contains 6 into 10 power 23 molecules, Na molecules. Means now for 1 gram it is Na by 32. For 40 grams it into 40. Now it will become 7.5 into 10 power 23. Now as per question, mass of 0. NaCO2 is 44 grams. Which is equal to CO2. So here 6.10 7.5 into 10 power 23 molecules, which will equal to oxygen. So here 44.44 into 7.5 into 10 power 23 by Na. So here both are cancelled. When we divide this, so here option will be 55 grams of CO2. So option B would be right. Now question number 40. We have to match them. Matchings are given here. Mass of H2 produced when 0.5 mole of zinc reacts with excess of HCl. Here by question. Sorry, I did not notice the camera. That's why some part is on the edge. So 0.5 mole of 1 gram H2 produced. For option A, it is 4. So option B, mass of all atoms of compound with formula of C70H22. Mass of all atoms. Here, as you can see, molar mass, which is equal to C70H22. Here the molar mass is become 862. Mass of atoms 0.023 into 10 power అదే Na. So here 1.43 into 10 power minus 21 is. So here for B it is option 3. Now so for C, here for Cl2 the atomic weight is 71, which is equal to 1 mole. 1 mole of C2. Cl2, which contains 1 mole of Cl2 contains Na molecules. Here half mole, so 3.01 into 10 power 23. For option C, 1. As you can see, option D, it is 2 because S32 O2 is 32, so 64 grams. So 1 mole, so Na molecules. So answer will be 4312. Option C would be right. Now question number 41. The number of oxygen atoms present in 1 mole of oxalic acid and dihydride is 1 mole of oxalic acid. Here COH twice 2H2. So here 4 oxygen and 2 oxygen. So total 6 oxygen. 6 into N into Na is number of oxygen atoms. So here 6 into 1 into Na, it is 36. 36 into 10 power 23. So option D would be right. Now question number 42. The density of a gas is 1.78 gram per liter at STP. The weight of 1 mole of gas is. Here density is given. So we have to multiply with the volume. So here weight will come out 1.78 into 22.4 for 1 mole. When we multiply this, the answer will come out as 44.8. So we have to take less answer. So option A, 39.9. Now question number 43. Which are the following gases have least value if 10 grams of each gas is taken at same temperature and pressure? Here CO2 44 grams into 28 grams, CH4 16 grams and HCl 36.5. Here as you can observe, number of mole is directly inversely proportional to molecular weight. Number of mole is directly proportional to the value. So here molecular weight high, volume low. So option A would be right. Now question number 44. How many number of molecules and atoms respectively are present in 2.8 liters of diatomic gas at STP? So here 2.8 liter of diatomic gas. So we have to find out the mole. Then mole into 2 atoms into Na, which will give number of molecules. So here when N into Na, mole into Na, it will give molecules count. So for atoms we have to multiply with the diatomic. So N into Na into 2. So here when we multiply, now what I am doing is I am obtaining the number of atoms. So here I am doing mole into 2 into Na. So this for atoms. So as you can see 7.5 into 10 power 23. It is for sorry. Here as you can see that number which is I'll tell 7.5 into 10 power 22 is for molecules count. When we multiply it, it is 15 into 10 power 22. As you can see for atoms it is 15 into 10 power 22 for atoms. For molecules it is 7.5 into 10 power 22. Now question number 45. Total number of atoms present in 36 grams of ammonia. Total number of atoms. So here mole into 4 into Na for number of atoms. As you can see for mole it is 36 by atomic weight of NH3. So here it is 14 and plus 3 it is 17 into 4 atoms into say Na. So here as you can see it is 2 and 4 8, it's 48 into 10 power 23. So option D is right. So option D. Now question number 46. What will be the mass of 100 atoms of hydrogen? 100 atoms of hydrogen. So here mole number of atoms by Na. So 100 by Na. It is 1 16.6 into minus 23. For mass of hydrogen atoms, it is 1 into that mole. Here option B would be right. 1.66 into 10 power minus 22. Now question number 47. How many atoms in total are present in 1 kg of sugar? In 1 kg of sugar, here sugar is taken as glucose. Sucrose. C12H22O11. So here the atomic weight is 12 into 22 plus 160. Here 45 atoms are present. The atomic weight is, molecular weight is 342. Here for mole, 1000 by molecular weight 300, 342. So here mole is come out as 2.92, which is round figure 3. Number of molecules is equal to n into Na. So here 3 into Na. It is 18 into 10 power 23. It is number of molecules. For number of atoms, we have to multiply with 45. 45 into 18 into 10 power 23. Here 8 into 10 power 25 are the atoms. Below I am taking the round figure value. I have to find out this below. So option A, 7.92 into 10 power 25. Now question number 48. 1.4 moles of phosphorus trichloride are present in a sample. How many atoms are there in the sample? Here moles is given. So phosphorus trichloride, here 4 atoms are present. So N into Na. So into 4. It is moles into Na into number of atoms. Here the answer will come out as when we multiply this, the answer will be 3.3 into 10 power 23. Sorry, 24. So option D would be right here. So here option D would be right. Now question number 49. What will be the standard molar volume of helium if its density is 0.1784 gram per liter at STP? Standard molar volume. So here density is given 78 0.1784 occupies Here helium occupies 1 liter, 4 grams of occupies 1 into 4 by 0.784. So here 22.4 liter is the answer. So option B. Now question number 40. In a mixture of gases, the volume content of a gas is 0.606 percentage at STP. Calculate the number of molecules of a gas in 1 liter of the mixture. Here value of gas 1 liter which is equal to 0.06 by 100. It is 6 into 10 power minus 4 liter. Number of molecules equal to n into Na. So here we have to find out the moles. For this, that value by 22.4 into Na. Here as you can see the answer is 1.61 into 10 power 23. Sorry, 19. So option D is right.